Hey everybody, let's get started with chapter 3. We'll be coming into chapter 2 a different way. There's some topics. It's basically an electrical review, and we'll hit those review topics as they come up as we move forward with the class. I think it kind of works better that way. And then there's also a specific section there on magnetic circuits, and we're going to take that a little outside of the text to get a better understanding of that. So this is where we are right now. This is chapter 3 in your textbook. And, at first you might think, why mechanics and heat in electrical motors class? But the idea of understanding basic mechanical principles and also thermal or heat considerations when dealing with electrical motors is a very important thing for us to have an understanding of. A lot of times people that work with electrical machines don't have those basic understandings, and when they're having application problems, not knowing some of those basics of mechanics and heat limits them in what they're able to do in fixing some of those problems. In the textbook in section 3.0, the first one that we come up with, he goes into more detail about that whole idea. And he says the starting of motors is determined not only by the magnitude of the torque, but also the inertia of the revolving parts. That motor's connected to something, or that generator's connected to something. And there's this concept of inertia that we need to know something about. Overload capacity of an alternator is not only determined by the size of the conductors, but also the temperature that the windings can withstand. As a matter of fact, we will find that the temperature is one of the primary considerations in the operation of electrical machines. What can that conductor insulation withstand? Failure to understand that causes a lot of problems in motor applications. He even goes into some discussion there about the transmission line, and it's not just the current carrying capacity of the conductors of the transmission line, but it's also ice loading and mechanical strength of the towers and the connections to these lines that make it important. So let me share this screen with you, and we'll look at a couple of things here and get started with this. Bring this up. So we're looking at that now. And so, this whole idea, in this chapter is to explore this in terms of the electrical, the mechanical, and the thermal. And, all of those are important. We are sort of dialed in on this area, the electrical side of the equation, but we're going to get some basics here and here, and it's going to help us as we go through this. We are going to hit these topics, this as a separate chapter, because I know most of us, we just haven't had this, and we pretty sure you haven't had the thermal part of this. If you're a mechatronics student, hopefully you're getting some of the mechanical components of this, and the fluid power, the mechanical drives, that sort of thing. But, if you're strictly electrical, this really isn't a review for you. It's probably the first time that you visited this stuff. So that's what this chapter 3 is about. And that's what we will be talking about here and working some problems. There's some fundamental equations, and we're going to work through each of the given examples in the textbook. And I think you'll kind of enjoy it. It's sort of outside our normal realm as electrical students. So that's sort of our introduction.